Students, in the last video we have discussed about deterministic PDA. So in this video we'll discuss minimization of context-free grammar. First of all, why we need it. So what is the need of minimization of context-free grammar? To convert into normal forms, either CNF or GNF, the grammar must be minimized. So what does it mean by minimized context-free grammar? A grammar is said to be minimized or simplified if and only if it does not contain useless productions or symbols, no unit productions, and it does not contain null productions, and it does not contain repeated productions. So now we are going to discuss how we have to simplify the context-free grammar by eliminating all these things one by one, right? So as I told you, these simplified context-free grammars are used to convert into normal forms, either Chomsky normal form or Greback normal form. So first we'll go with the substitution rule, right? To simplify it, see here we are having non-terminals like B. So then we can replace this B whenever you have the B. Like if I replace this B with the B, you'll get it. Okay, AB. And in place of B, substitute B, you'll get a new production like AB. And we don't have B here. For this B, again you substitute B. You'll get AB, BC and also B. Write down the new production by substituting it. And in place of no, right, BA, you don't have any B, then take it as it is B. So once we have again the new B is having only one production, already we have two production. So the first production is already substituted in appropriate places. Here we have substituted here, so that we got the new productions like AB and ABBC. Now the B is having only one production, even that can be substituted again. So wherever you are having the B, you substitute. So what will be happen, guys? Listen here. S tends to AB and AB. So we are substituting B tends to AA, right? So in place of B, you write AA. So it would be AA. In place of B, I have substituted it. So same way you can take here. We don't have it. Again, we have a B here. You substitute AA. What will be happen? A tends to AB, BC. You keep the as is. Then AB, BC and AB, AAC. In place of B, I have substituted it. Then same. This we remove it again. Now see, already we have substituted two productions. Then we got it. So once we got it, then this B, these two productions are useless, because whenever you have B, all the B productions have substituted. Then once you have substituted, you can remove the old B non-terminal productions. Now we can treat that these are useless symbols. We can say that useless productions. That we can remove it. So this is the equivalent grammar. So first one, substitution, but generally don't take risk of substitution. You have to eliminate only the null productions, unit productions and repeated. But I just told you the substitution rule, how it is going to be. So how it will be helpful to do this, right? Then what is meant by null production? First of all, null production means we'll be having the epsilon. Okay, M tends to epsilon or lambda, we can take it. Then this is called null. So the CNF and GNF both doesn't have the null production, so you have to eliminate it. How to eliminate it? It's very simple, guys. Take down all the productions as it is, whatever you have earlier. S tends to AMB and M tends to AMB. Now I'm removing the epsilon. So wherever you are having the M, replace it with the epsilon. Whatever the new term we are getting, you write it. If I replace this M with the epsilon, what is the new term I will get it? AB. That's the reason we have discussed about this substitution rule, guys. Okay. And same way, here we have M, replace this M with the epsilon, what I'm going to get? AB. Then you can remove it. That's it. This is a new grammar after eliminating the epsilon rules. That's what you got here. Right? Substitute M tends to epsilon. The substitution rule we have discussed, right? And what is meant by unit production? If both the left hand side and right hand side, if you are having only one non-terminal, then we can call it as a unit production. Single variable on left hand side and right hand side, non-terminals only, not the terminals. So if we are having same variable, you can directly remove it. Left hand side, right hand side, if you are having the same variable, you can directly remove it. But if left hand side and right hand side are having the different variable, but only one variable, then you can replace this B, substituting all the B productions here, as simple as it is. Let me explain this. See, here this is not a unit production. This is also not a unit production. This is a unit production. A tends to B. Then simply, and this is also unit production, B tends to A. And what we can do, simply substitute all the productions of this B, right here, simple. Substitute all the productions of B here. What will happen? So A tends to AA, right? And in place of B, you substitute all the productions, or in place of A, you substitute all the A productions. Whatever it is, both are same. You can do any one way, right, at a time. So as in the thing they have mentioned the B first, let me go with the another one first. What is the need? Why should I go for the all? I'll go with this. So in place of B, I'm substituting all the B productions. What will happen? I'm not changing this. I'm changing only this A productions things. So A tends to first substitute A, then substitute BB. You are going to get like this. Then we will be having B tends to A, that we have removed it. B tends to BB. Now see, this is removed. Now again, as we are having same variable, we can remove it directly. So what is a new grammar we are going to have here? S tends to A tends to A, and A tends to BB. As left hand side, right hand side, same symbol, we can remove it. Then we'll be having B tends to A and B tends to BB. This is a modified grammar. And we are having again new non-terminal A here. So in place of A, substitute all the A productions. So what will be happen? Don't change remaining all. S tends to A tends to A tends to BB. In place of A, substitute all the A productions. So B tends to A and B tends to BB, right? And B tends to BB, right? So we have substituted once for this BB and this. Again, it is redundant. You can remove it. So this is a simplified grammar after eliminating the unit production. Right? See, the final grammar would be like this. Same, whatever we have taken here, it would be same here. So they have done first A tends to B, then like that. So I've done it in a reverse. Your wish. Logic is very simple. If you are having a non-terminal, replace that non-terminal with all of its production. That's it. You don't need to do anything more than that. Okay. Then how to eliminate the useless symbols. So what is meant by a useless symbol? A symbol or a production which is not terminating or which is not derived from the starting symbol, that is called useless. For example, S tends to ASB and S tends to epsilon. I can terminate this production, so this is not useless. And S tends to epsilon, anyway it is a terminal, we can do it. Then S tends to A, right? A tends to A tends to A tends to AA, like that. We don't have any termination here. We cannot terminate this A. So this is called useless, we can remove it. If this is useless, and automatically S tends to A is also useless because all the A productions have been removed, then this is also useless. So what is a simplified grammar? We are going to have S tends to A is BR. Yes, that's it, right? So unit production, epsilon, right? Null production. So I told you null production means simply substitute the non-terminal with the epsilon. Unit production means simply substitute the right hand side production with the all of its productions. And unit epsilon repeated means are useless symbols. We can take it, the symbols which are not derived. Okay, before going to that, let me tell you a simple example with all guys. Just go with this. Right. First, useless symbols. Let me go with this. S tends to AAB. Let me take a simple example. A tends to B D or B. B tends to A C or A, and C tends to B B or B, and D tends to D A or D. Right. First of all, I want to go with the useless symbols here. Right. See, from S I can reach the AAB. From A I can reach the BD. From D I can reach the DA, and I can terminate with the A by substituting the B, or I can go with the D BD and I can terminate the D with the D. So I can terminate and this, so no problem with the S productions, no problem with the A, and no problem with the D. But see, I can't even reach the B and C from the starting symbol. That's why we can say that these are useless symbols, are useless. Then you can remove it directly. You can remove it directly. Okay, then what is a grammar? After that, you can take it. This is called useless symbols. For example, if I'm having like this, S tends to A, S, B, or A, or D, then A tends to A, or B, A. See, for S, I can go with this A, S, B, and for S, D, I can terminate this production. I can go with this. But for this AA, I cannot terminate because for S, I can take AA, for AA, for AA, BA, like that I cannot terminate. So these all are useless productions. Then you can remove it, right? That is the meaning of useless. Then what is mean by epsilon? Let me explain with a simple example, guys. A, B, or B, or A, B. A tends to epsilon, B tends to epsilon. Assume that we are having or AA or BB. Okay, no problem. Now first I want to remove the epsilon from A, right? Epsilon from A. Don't do two at a time. Do it one by one. Okay. Then how can you get it? Remove from A, right? Write down all the productions as it is. A, B, B, or AB. So I'm removing from A. So wherever you have A, replace with the epsilon. Then whatever the new term you are getting, you write it. So if I remove this AB, I'll write it. In the same way, A tends to, we have removed the epsilon, so remove it. Then AA, you write it. As we are removing the epsilon, then replace this A with epsilon, you are going to get A, new term. Then B tends to, we have not removed it, BB. Logic is very simple. Okay, very simple. Just same concept. Write down all the productions as it is. Okay, S tends to AAB. Now I want to remove the epsilon from B. AAB, BBB, AB, or AB. Then you write A tends to AA or epsilon. So B tends to BB. How to do it? Just listen one more time. It's very as simple as like this. Just simply, as we have removed epsilon from B, wherever you have the B, remove it and write down the remaining productions as new. Remove it, BB, you'll get it. And remove it, write down the remaining productions as new. Nothing. And remove it, write down the remaining production symbols as new production. That's it. This is how we have to remove the epsilon productions. Then how to go with the unit production, as I told you. So S tends to AAB or B or AA. Then A tends to AA or D. And B tends to BB or DA, something like that. So here we are having only one unit production, that is called S tends to B. Remaining all are not unit productions. Then how can you do it, guys? Very simple. Might be you got confused with the other symbols. Just replace this B with all of its productions. That's it. Replace this B with all of its production. And what will be happen? S tends to AAB. In place of B, you write BB and DA and AA. Then you can take A tends to AA or D and B tends to BB or DA. That's it. That's it. Nothing more than that. Simply replace this B. But why we have taken here like that? Okay. Repeated productions. Here unit production. We got some repeated symbol. That's the reason we got many here, right? See, first A tends to B we have substituted. Means here in place of A you have taken B and A. That's why we got it extra. Okay. So here after substitution we got the two symbols AA and AA, two production which are same, right? That's why they have eliminated the repeated production. Okay. Whatever we have done earlier also same. That's about the minimization. And of course, why we use this minimization, as I told you, normal forms, but in CNF, no problem with the left recursion, but in GNF, we need to even eliminate the left recursion. So before going to the normal forms, so in the next video, we'll discuss about elimination of left recursion. I told you now, even we are dealing with the ambiguity also, the left recursion will help you out. So we clearly discuss now in the next video how to deal with the ambiguous grammar where you are having left recursion also.